Git today. So this is just going to be more of a conversation of just, and so feel free to stop me at any time because I know we're at different levels here. So some of us might know it, some of us may not know it so much. So all questions are welcome. So let's start with this first. So I have an HTML file, and we're going to go ahead and open it. So when you put it in the browser, you get hello world. Okay. So now let's imagine that this is some kind of like enterprise grade project, and if I lose my files for this project, then I'm in big trouble. Okay. So make a change. Okay. Wait, sorry, can I just get raise of hands real quick? Who's used Git before? So 2 here. So what have you used it for mainly?
There's another Discord that I joined from the C# program. So every week what we do is that we have a discussion after that. We fork whatever we have in that repository, and then you make changes to the program. And after that, you update the master and then you update the branch. And then here we go through it and then review and also make any changes to it. So it's like we collaborate on whatever changes that we make.
Okay, cool. And Fred, for you?
Just maintaining the history of my own projects. So they're showing over what time period I was able to do what, and specifically what changes I made at what time and stuff like that.
Okay, cool. So I want to start with that point first. So Git's #1 thing is that it can track the history of a file. The reason why that's really valuable is because let's say you're working on an application, which is in reality just a bunch of files, right? A bunch of files come together and they create the application. So if you have that in a certain working state and everything is good, and then the business or the clients or whoever you're working for ask you to make a change. You're like, okay, sure. You make the change, something breaks. How do you go back normally to like the previous working state? Like for example, can anybody just raise their hand? If you're working on, let's say, a Word document, and it was good at like 10 pages, you try to add something and it suddenly, starts falling apart. What do you do?
Control Z.
Control Z, right? You start undoing, okay? But what happens if you screwed it up, then your computer crashes? Is Control Z gonna do anything for you?
No.
Right, exactly. So, but if you had Git, then that's no longer a problem. Control Z is not gonna be your weapon of choice to undo something. Because when you work on a file, let's say you finish it, right? So let's say everything is perfect, and this hello world is exactly what the client wants. And then they say, okay, can you add a line underneath that that says hello universe? And so if I do this, and let's say I misspell it, okay? I'm like, oh no, the app's broken now, right? So luckily, since I'm here, I can just undo, 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 and I'm back at this original state, and I can kind of reset and start over, basically. But if this editor crashed, then I won't be able to undo my way out of it. And it's a silly example, but just imagine like you're working on some huge feature, and that feature then breaks some other place in the application. Then good luck trying to reverse that. So instead, we can use Git. So let's get this started. So right here, this is the terminal. Anybody not familiar with the terminal? Just like the concept of what it is.
Oh, what?
The terminal.
Not
So
really.
I saw one hand raised, so 2, this?
Yeah.
Okay. Kadeem, how would you explain in one sentence what a terminal is?
Terminal is the closest you'll get to the machine that you're operating on. So
Like
you
which
can
user?
basically do anything that you want to do using, your mouse and clicking via the terminal. But instead of clicking, you're using code.
Not only that, you can also do a lot more than
Yes.
you can do with your mouse.
Yes. And you also have access to administrator tools and stuff like that you can do a lot of hacky things with. So that's that.
Terminal is the command line access to your graphics user interface. So like you said, moving the mouse on the screen is visual. You can actually move your mouse using X and Y coordinates using terminal, as an example. I don't think that's possible though, is it?
I've never done it, but I like both your explanations. How? All right, so they're right. It's basically what you see visually, where you can manipulate stuff, edit files. You see this folder here on the left. It says Git Talk. That's the folder that this project's open in, and we have two files. We have an HTML file and this text file. The terminal lets you navigate and manipulate the computer without any of that interface, without seeing any fancy buttons, without using the mouse. And so this terminal right here, if I type this command, everything is based off commands. So the command ls is short for list. So list is going to say, okay, what folder am I in? Show me everything in that folder. So boom. See that? You can actually use the laser pointer here. See, index HTML, talk outline.
So this is like the terminal window? for-
Yes.
Okay.
Yeah, and so the editor I'm using is really, really fancy. So it gives you an integrated terminal. So there's a separate terminal application, by the way, that's on Mac and Windows. So here, this is it. See, this and this are essentially the same thing. It's just this window is inside of my editor because it's just a lot more convenient.
Where'd you get it?
It's free. It's called VS Code.
I mean, what did you type? Get
Oh,
the window?
to open this up?
Yeah.
It's a hotkey over here. So this will close it, this little trash can symbol. To open it back up, I forgot what the button was, but it's
You can go to view.
it's Control tilde on
Oh,
here.
okay.
So, but yeah.
Just anybody using Windows, it's called command prompt.
Yeah, command prompt or CMD. So if you guys ever played like Fallout or like, I don't know, like an old cartoon or a movie, like you know those like computer console screens where it's literally just a wall of text, but the hacker knows exactly what he's doing, right? You ever seen that before? Like maybe he'll go in to hack a system. He won't be clicking on a button. It's everything is here on the keyboard. He's looking. I think I hit something.
Oh.
He's looking at a screen exactly like this. Like it would literally be full screen, and he's just typing in command after command after command, getting the computer to do whatever he wanted it to do. You ever seen that kind of like scene in a movie before?
Hackertyper.com.
Yeah,
Yes.
for television, computer.
Yeah,
hacker.
exactly. That's not entirely fictional. This terminal is exactly what the guy in the movie was using. So, and this is something that we use every single day on the job as software developers. Even if you're not in web development, you're probably still using a terminal for your day-to-day work. And
Now
go
just
ahead.
your terminology of developer, what does that mean you're not? What are you doing? There's other titles, but what's developer?
I just developer's a programmer, somebody who gets paid to write code. That's
So
my
you're not
definition.
like a programmer.
Developer, programmer,
It's the same, hardly the same.
Same thing.
Same thing.
Yeah.
It's just programmer, fancier way of saying developer.
yeah.
Like computer programmer, like
Yeah.
back in the day there wasn't developer as far as I know.
Right. The developer, I feel like is like a more trendy-ish
It's more-
kind of
yeah,
title.
It's a more niche term for the same thing.
Yeah.
Okay, okay.
You know how we
wouldn't
have.
call yourself a programmer on your resume.
No, just because I feel like that terminology is kind of old hat.
Yeah.
That's me.
Okay.
It's where I get it.
Okay. So, install Git. Anybody use Git on Windows before? Okay. So, you have to, it doesn't come with the computer, right? You have to go and download it, right? Okay, yeah. But for Mac and Linux, you can just use it out of the box. And so the way to use it, so remember I used the ls command. That shows me what's inside the current folder, right? The HTML file and this talk outline. The command to use git is git. Now you get all this stuff. And this is basically just like a little, like an introduction page to Git. We're not going to read all this, but basically the way we're going to interact with it is using the command git. And so you use that command and you pass it certain parameters to tell it what to do. So to set up Git in a directory, use the command git init, I-N-I-T, so this. Init is short for initialize, but this is how you write it out. This is the command it accepts. So git init is going to say, hey, Git, this folder, I want you to set yourself up here, set up camp, and watch all my files. So we do this, boom. Now, look at what just happened here. See that first line, it was just git talk. Now do you see git talk, git master? And there's a little yellow X. That's a fancy feature that my terminal has. Basically, it means that, hey, Git is running in this folder, and there's some files that Git is not currently watching. So check this out. Here's our second command. To git status, you have two files, right? These are the same two files these are the only other two files that are sitting inside this folder, Git talk, right? We covered these before. Right now they're untracked, meaning Git is aware of their presence, but is not actively monitoring them. Because remember, Git is all about maintaining a file's history. It knows what happened last week, it knows what happened 2 weeks ago, it knows what happened 5 minutes ago. But if the file's not being tracked, then Git is not doing any of that. So what we can do here, we can say git add -a. Well, that command says, hey Git, everything that's in this bucket, I want you to keep your eyes on it. And anytime somebody changes a single character in that file, I want you to let me know about it. So now, these files are tracked. Now, if you go back to our previous command, git status, it just tells you what's up. You say, okay, now they're green, they're not red anymore. So it says these are changes to be committed. A commit is at some point in history. It tells you that something happened. So,
You could think of it as like a save file. Like a
yeah,
save
basically a save point, like a save point in a video game. It's like, all right, save my status right now. So the way to do that is you use the commit command. So git commit, and we wanna, when we save this, we wanna give it a name so that we can easily reference it later on. So I'm gonna say -m, that means, all right, whatever I put in quotes is gonna be the name of my save point. So I'm just gonna call this initial commit at free code camp. You hit enter. Now, notice how that yellow X is gone down here. It's gone because Git is totally aware of the files and it's on top of all the changes. So check this out.
So the X is a warning?
Yeah, exactly. It's an indicator that, hey, you changed the file and
You haven't saved it yet.
yeah, and I'm not on top of it yet. So if you want me to be, make sure to type in the proper command. So check this out. If we want to get that X back, we just do this. I'll just make a change. I'll add a space, okay? Save the file. No, oh, sorry. Let me just do this. Hello world 2, okay? Now, you see that? It's back. If you type git status, it says, hey, you modified index.html. Because what we did last time was we added it. We said, hey, Git, keep your eyes on index.html. So Git listened to us, and now it says, hey, I see that you changed it. Do you want to make another save point? And if you want to see exactly what changed, git diff. The green, any green text in here means you added this line. So it knows exactly what happened. So now let's say, for example, I delete this line now. So now we're in hello world 2. Oops, sorry. You type git diff again. Pop quiz Holly, what do you think is going to happen if I do git diff?
Mm-hmm.
So I added a line, I removed the line.
I don't know.
Do you think you're going to see at least one green line that says like, hey, you added this?
You mean
It's
a
gonna show-
notification?
It's gonna show the second line.
Yeah. Say, okay. See? This
Oh,
little,
okay.
little minus sign. And it's red, meaning you got rid of this. And a little plus sign, meaning, hey, you added this.
So the difference is plus and minus, what was different?
Exactly. So basically, minus hello world and plus hello world 2. If you do that, you get the current state of this file. Does that make sense?
Mm-hmm.
So basically, the way we got here is we took out this line and we added this line. That's how Git thinks. Git thinks in terms of plus and minus, in terms of add and subtract. Because if you add those two together, you get what's called a diff, a difference. And if you diff two files, you see exactly what their differences are.
You know, back in the day, we'd have to save, hit the save button, so it sounds like the same thing.
Yes, in fact, hello. In fact, Git is not going to be aware of any changes until you hit the save button. Because when you hit the save button, you're rewriting that file on disk. And so Git has a chance to read it, and it's like, oh, there's a change.
Mhm.
So then it'll tell you about it. Okay, so we do Git status, we see that I modified this. So to basically make a new checkpoint and make Git happy, we do the same thing we did last time. We do add A, so add everything to be tracked, and then make another commit. I made another change. And now, if you read this, by the way, is this text too small? Can everybody read this okay?
Yeah, that's it.
Anybody need me to zoom in?
That's
Okay, good. So, hello.
How you doing?
So when I made that commit, Git gave me a little report down here. Said, okay, one file changed, one insertion, one deletion, which makes perfect sense. We touched one file, index.html. We removed one line, hello world, and we added one line, hello world 2.
Quick question.
Yes, go ahead.
Before, you use the add command in order to take any files that were tracked and make them be trackable.
Mm-hmm.
You had already done that with this HTML file. So since it was modified, did you have to do git add again? Or could you just gone straight to commit?
No, you can't go straight to commit because then Git doesn't know what files you want to commit. So that add command is necessary. Because yes, it adds untracked files, but it also re-adds modified files that were being tracked. There is a shorthand if a file is not being tracked, but I didn't want to dive into that just yet. Okay, so like I said, Git keeps track of the history of a file. Now that we've made some commits, you can look at the history. So if you do git log, boom, you see this? It starts here. Our first commit was initial commit of FreeCodeCamp. That's the name I gave it. See, that's why those quotation marks where you name your save point, that's why they're so important, because you can come back later and you can see exactly what you did. Okay, cool. Initial commit of FreeCodeCamp. And then the author was me. That's my Git username. This is my email. And this is the date. Thursday, January 24th at 8 o'clock, right? That's military time. And then if you scroll up, you see another commit. I made another change. And if you look at the time difference, this commit happened 3 minutes afterwards, about 3 minutes. Okay, and one more example. Let's say we change this to hello world 3. If you do git status now, Git says, hey, you modified the index.html. You type git diff, it tells you exactly what changed. We subtracted hello world 2 and we added hello world 3. That's how Git looks at it. So if we want to add that change to our history, add it, give it a commit name, call it my third commit. Did I spell that right? And now if you do git log, you see we have the first commit, we have the second commit, and now we have the third commit. So everything's being tracked. And I don't know if I want to dive into it right now, but you can jump between commits. And so if you jump to a previous commit, this file is going to physically change. So if we jump to commit 2, it's going to say hello world 2. We jump to commit number 1.
What do you do to jump?
Do you want to see the command right now?
Yeah.
Okay. It's called git checkout. So what you would do is, you see these big yellow numbers? Boom, boom, and boom. These are unique IDs. So if you have that ID, there's no other commit that shares it. So basically, the purpose of this is so Git knows exactly what commit you want to jump to. So if I copy this, and I say git checkout, and I paste the hash, this is going to jump us back in time to the first commit.
By the way, that's called a hash.
Yeah, it's called a hash. Sorry, that hash is the ID. So you see now? Hello world.
And what happens to the commit that you jumped from?
Nothing. It's still maintained in the history.
Is it?
Yes.
But if you branch off of this, so then does that like have branches now?
We didn't branch off of it. We hopped to basically a different point in time.
Let's say let's add a p tag now. So that's branching off technically, right?
Yes, but you don't want to do that. At least not in that fashion. Because think about it. And like, let's step away from the technology. Let's go into like a more real world example. If 3 events happened, and you're able to go back in time to the first event
Right.
and do other things.
Right.
If those two timelines ever meet, you're gonna have serious merge conflicts. And that actually happens in Git.
Wow.
It's a reality.
So it's like a snapshot of each revision, and it's a revision history.
Mm-hmm, yes.
So if you go to, like you said, the hash,